Somewhere in a coral reef right now, a creature smaller than your thumb just did something that should be impossible. It didn't bite anything, it didn't touch anything, but for 1/10,000,000th of a second, the water in front of it turned into plasma. You are 2 inches long, you have no fists, no teeth, no venom, and in half a millisecond, you are about to create something hotter than the surface of the sun. This is the pistol shrimp, sometimes called the snapping shrimp, and it does not kill by touching its prey. It kills by snapping one oversized claw shut so fast that it briefly breaks the laws of what water is supposed to do. Here's the part that shouldn't make sense. Somewhere inside that snap, for a few nanoseconds, a temperature spike occurs that rivals the sun's surface, at least 5,000 Kelvin, maybe far more. A 2-inch shrimp, doing something physicists usually need lasers and vacuum chambers to pull off. We're going to find out exactly how. But first, you need to understand the weapon. One of the shrimp's 2 claws is a tiny, ordinary pincer, used for picking food apart. The other can weigh half the animal's entire body. It looks like a boxing glove bolted onto a house cat-sized crustacean if the house cat were the size of a paperclip, and that giant claw doesn't crush. It doesn't even make contact with what it's hunting. Instead, the shrimp cocks it open using something called a slip joint, a hinge, so specialized that when the muscle pulls, it doesn't pull the claw shut. It pulls it further open, locking it in place like a loaded crossbow. Elastic energy builds and builds inside the exoskeleton, stored the way a bent bow stores a shot before it's fired. Then a second, smaller muscle nudges the claw past a tipping point. The lock releases, and the claw slams shut in about half a millisecond, faster than your eye can register motion at all. That closing claw fires a jet of water at over 60 miles an hour, across a gap of just a few millimeters. Here's where it stops being mechanical and starts being strange. That jet moves so fast that, by Bernoulli's principle, the pressure in its wake collapses. It drops so low that the water itself tears apart, not from heat, from pressure. Cold water, ripping into a bubble of vapor, boiling without a single degree of added warmth. Scientists call it cavitation, and for decades, everyone assumed this bubble was just a side effect, background noise to the real weapon, which was supposedly the claw itself, striking home like a tiny hammer. Nobody thought to look closer, until they did. In the year 2000, a team led by physicist Detlef Loos pointed a high-speed camera at the shrimp, filming at 40,000 frames per second, with a hydrophone running alongside it. And what they found upended the whole story. The loudest part of the snap didn't happen when the claw closed. It happened 700 microseconds later. The sound wasn't the claw at all. It was the bubble collapsing. Because once that vapor bubble forms, the surrounding ocean doesn't let it stay open for long. Water rushes back in at supersonic speed, crushing the bubble from every side at once, unevenly, violently, in a fraction of a millisecond. And when a gas gets compressed that fast, it has nowhere to send the heat. The energy has no time to escape into the surrounding water. It just piles up, instantly, inside a space smaller than a pinhead. That's when the bubble's core briefly touches 5,000 Kelvin, maybe higher, hot enough to strip electrons clean off their atoms, hot enough to build, for a heartbeat's fraction, a tiny ball of plasma, the same state of matter that makes up stars. That plasma throws off a flash of light so brief it lasts under 10 nanoseconds, a phenomenon researchers named Shrimpoluminescence. And here's the part that still catches people off guard. Nothing sees it. Not the prey, not the shrimp, not you, not any eye that has ever evolved on this planet, because it's simply too fast for a retina to register. The shrimp is lighting up its own private supernova, and it is functionally invisible, a pure accident of physics with no biological purpose at all. But the shockwave the collapse sends outward, that part is very much felt. Peak pressure levels near the claw have been measured up to 218 decibels underwater, and you've probably heard that compared to a rocket launch. That comparison is wrong. Water and air carry sound completely differently, different reference pressures, different density. And once you do the math properly and convert that number into what a human in air would actually experience, you land closer to 156 decibels. Still brutal, still comparable to a gunshot at close range, capable of stunning or killing small fish outright, just not physics-breaking. The real number is dramatic enough on its own, and it turns out, this sound has already changed human history once. During World War II, American submarines relied on sonar to detect Japanese ships. listening through headphones in total silence for the telltale hum of an engine. Except in shallow coastal water, operators kept hearing something else. Instead, a relentless, crackling static that drowned out everything, like fat sizzling in a pan that never stopped. It was jamming naval sonar across the Pacific. The Navy sent a marine biologist named Martin Johnson to find the source. Millions of snapping shrimp, firing in constant, overlapping chorus. And once the Navy understood what they were hearing, they didn't just work around it, they weaponized it. American submarines began hiding inside snapping shrimp colonies, using the noise as acoustic camouflage, and some crews even mounted speakers on their hulls, broadcasting recordings of shrimp snaps to throw off enemy listening posts. A 2-inch animal, helping submarines disappear. So that's the weapon, and that's the sound. But here's the question that took scientists much longer to answer. If this shockwave is strong enough to stun a fish, why doesn't it destroy the shrimp's own brain? It fires this thing inches from its own head, over and over, for its entire life. The answer is a structure called the Orbital Hood, a clear, helmet-like shell that wraps completely around the shrimp's eyes, open only at the front. Recent testing found it's built almost like packed layers of shock-absorbing film, roughly half as stiff as the shrimp's regular shell, but able to soak up nearly twice the energy, flexing and venting water forward instead of letting the blast slam straight into the brain. In lab trials, shrimp with that hood surgically removed lost motor control after firing their own claw. The ones with it intact just swam away. Somewhere in its evolutionary past, this animal had to build a helmet before it could survive its own gun, and it still sees perfectly well through it, tracking motion at 1/60 times a second, among the fastest vision in any water-dwelling animal alive. Think about that the next time you're standing on a beach. Somewhere under that calm surface, in every reef and tide pool and oyster bed, there are millions of these things, each one small enough to sit in your palm, each one carrying a weapon built from pressure, collapse, and a flash of light no living eye can catch. You'll never see it happen. You'll only ever hear it. That faint, endless crackle just under the waves. The sound of an entire ocean quietly detonating, one impossible, invisible sun at a time.